Sorry. Hey guys, just listening to my new theme song because I'm sitting in my new house making notes for you. Welcome to my house. Okay, so we're gonna do a couple examples that we did not get to on Friday for verification. Here is the deal, guys. In general, okay, you're trying to turn one side of the equation into the other. You are not going to do normal solving equation tactics like multiplying both sides here by secant. That's not what's happening. We're not trying to solve for x. All we're trying to do is we are trying to turn this left side into the right side. So left hand side, okay, that's how we write that in math, equals right hand side. That's what we want. This app makes me have really bad handwriting, so bear with me. All right, so it's kind of nice because it's the same thing we did on the first day, except now we know the end game. We know that we need to end with sine of x. So let's play around. Since I want to end with sine, the identity I'm going to use for tangent has to involve sine. So let's use the identity sine x over cosine x, which as we know is equal to tangent. So that's what I'm turning the tangent into. Let's turn secant into something. This is a big division problem. Secant is 1 over cosine. Let's try that. See what happens. This is a division symbol, guys. So when we divide fractions, we flip the second fraction and we multiply. Here's what we have. Sine of x over cosine of x. Okay, equals flip. We have cosine of x over 1. Ooh, the cosines cancel. I'm left with sine of x over 1. That's exactly what I wanted to get. I just showed that the left-hand side, sure enough, was reduced to the right-hand side. Guys, I hate to say this word, but I'm going to say it. These are also known as trigonometric proofs. Welcome back to proofs. Okay, we are proving the left side is equal to the right side. It's not the same type of proof from geometry. Okay, we're just using algebraic skills mixed with trigonometric identities in order to make the proof. So let's go on to number 2. All right, here we go. Got a road ahead of us. We got this. We got to make this equal to 1. You always want to start with the more complicated side. All right, I have a plan. Sometimes I like to just stare at it for a while. I know that sounds weird, but I kind of like to think about like, oh wait, 1 plus tangent squared. I know that's some sort of identity. Maybe I can change that, and then maybe if I multiply that with cosine, maybe things will cancel out. Hint, they do. So 1 plus tangent squared, we're going to use the identity that that quantity right there is equal to secant squared theta. So now we have cosine squared theta times secant squared theta. Well, secant is equal to 1 over cosine squared. So now we have this, OMG, these guys cancel, bye, and I get 1. Wow. Wow, killed that in under a minute, just saying. Let's go on. All right, this looks like a doozy, but let's just play around. So on top I see secant times cosecant. I'm a little scared, but I'm just going to start working. So this is all being multiplied. So what I think I'm going to do is split this guy up a little bit. I think I'm just going to take the secant. I'm just going to put it over 1 times cosecant x over cosecant squared x. Now I don't need to do this with a common denominator because it's being multiplied. So if I just multiplied this back together, I would multiply across the top and across the bottom and I'd get back to my original problem. So I'm good right now. Here's why I did that, because this can reduce to 1 on top and then just cancel one of the cosecants on the bottom. Oh yes, all right, I just realized I'm gonna get this. That makes me happy. I hope that's how you guys react when you guys see a problem and you're like, I don't know what to do. And then all of a sudden it clicks and you're like, oh yeah, heck yeah, I got this. All right, so what I'm left with is this. Secant x times 1 over cosecant x. But 1 over cosecant, okay, is sine. So now I got secant x times sine of x. All right, well, guess what? Secant is 1 over cosine. So this, I'm going to go back up here, guys. This is 1 over cosine x, because that's what secant is, times sine of x. Okay, let's make that one fraction. So that's sine of x over cosine of x, oh yeah, which is equal to tangent of x, which is what I wanted. And I'm done. Let's go on. Okay, wow. Looking at this one, there's a couple things I want to do. Part of me wants to FOIL this, and I'm just going to be honest, that's what I started to do when I started this problem. But then I realized there was an easier way. I got stuck during the FOIL process. This might happen to you. You might start FOILing and you might think, oh crap, I don't know where to go from here. This is kind of scary. When that happens to you, take a second and pause. Look back at the original problem and ask yourself, is there an easier way? Is there an identity that I could use right away? And the answer to that is yes. So after I had FOILed this out, I was staring, being like, crap, this is a lot of work. And then I realized, wait a second, I recognize this. 1 minus sine squared x is an identity. That is equal to cosine squared x because of the Pythagorean identity. And I thought, okay, well, wait. Now, if that's an identity, I wonder if this one is. And in fact, it is. Now, this one's a little bit harder, and we talked about this one in class. The identity for this one is secant squared x equals 1 plus tangent squared x. So I need to move the tangent over to the left and the secant over to the left because I want it to be 1 minus secant squared. So if that happens and I move the tangent over to the left, and then on the right side I get 1 minus secant squared, which is what I want, then I'm left on the left-hand side with negative tangent squared x. So that one is definitely tricky because of that negative. But hang in there, see if you guys can follow what I'm going to do now. So now I'm going to rewrite tangent. Since next to the tangent squared is a cosine, I'm going to rewrite this as sine over cosine. So I'm going to just leave the negative hanging out in front. Negative sine squared x over cosine squared x. You only need the negative on top or just one spot. Times the cosine squared x. And now you guys can see those cosines will cancel. And guess what? I'm left with negative sine squared x, which is exactly what I wanted. That one was hard, especially because, like I said earlier, I started to FOIL this to start, and there was so much going on when I FOILed it, and so that's when I backtracked and thought, oh shoot, 1 minus sine squared is an identity. Let's go this other route. That is going to happen to you. You are going to start a problem at some point, and you're going to realize you're going down the wrong path. That's not a big deal. Turn around, walk back, and go down the other path. It's fine. That's going to happen. Let's go on to the last one. Okay, last one. Now, this one, I'm looking at the numerator, the top, and I'm thinking, okay, maybe I can factor that. And in fact, I can. I can pull out a sine theta. I'm left with 1 minus sine squared theta. Ah, that is an identity, right? This is over cosine theta. All right. This is equal to cosine squared. Okay, so I'm going to rewrite this. Sine theta times cosine squared theta all over cosine theta. So look, this cosine on top, there's two of them. One of them will cancel with the one on the bottom, and guess what, guys? I'm already done. So those last two problems, I skipped numbers 8 and 9 on the example. I don't think I said that in the video, but those are the last two. I hope that this is making a little bit more sense. So again, just you're trying to get the left side equal to the right side. And sometimes it's trial and error, and that's okay. I know you guys can do it. You guys proved that you guys can do anything with that last chapter 4. It does take work. It takes grit. You got to work through the struggle on it, but you guys can do it. So anyway, I'm about to make another video for you guys. I'll have to think of a more clever intro. Bye. Have a good day.